So here I'm logged into my Google GKE environment. What we'd like to do today is create a cluster with some basic settings and show how we can protect the workload using the Filestore CSI driver. First thing we'd like to do is go ahead and create a cluster. I'll call this, you can call it whatever you want. I will deploy this in US West 1. We'll then change this name just for easier identification. I just need one node per zone. For service account, we will go ahead and make sure that I'm using one of the service account with the right privileges. These are outlined in our documentation. And the last thing we want to do is have it install the Filestore CSI driver. I believe that should get us going. Everything else is default. It's E2 V4. That's okay because we're not really running heavy workloads. We're just going to test one application with this driver set, just to show you that that it works. Alright, so the cluster is now deployed. It's got 3 nodes, and we'll go to our command prompt to try to access it. First thing we want to do is be able to get credentials and log into the cluster. I'll update the name and the region, and we'll get the proper kubeconfig file. Okay, the next thing we want is to be able to show you that this is indeed a new cluster, right? And I'll do the same thing here, so you know it's just accessing the same cluster in 2 different sessions. You'll also see there's really nothing installed. So the next thing we want to do is install Kasten with very default configuration for now, and we'll let the K10 software get installed. Once everything comes up in a running state, we'll go ahead and configure other stuff. So what I want to show you is that they're actually spread across all nodes. So if you see, we've got C6XZ, S3SS, and SFLC. Those are the 3 nodes that we've got here, right? So workloads are running, they are spread across the entire cluster. The next thing we want to see is I've already got for Filestore CSI, when we selected that option to get installed with the cluster, it actually installed the CSI drivers and the storage classes that are leveraging those. CSI drivers for volume snapshotting and other data protection APIs are bound to a resource called volume snapshot class. So I've got the sample YAML here. You'll see that it's a volume snapshot class type. I give it some name. This is the annotation to let K10 know that when volumes using this provisioner are installed, that they can access the APIs from snapshotting perspective that are in this resource by creating this resource in this format. So what we'll do is we'll see that there's currently nothing on the cluster, so we'll go ahead and apply that resource. And now when you see there's 1, and when we do YAML, we'll get the details here. Okay, so that's good. So now what we want to do, let's go ahead and clear, and we will install a test application. We are installing MySQL, a Bitnami, MySQL chart from upstream. We want to install it in MySQL namespace. The namespace doesn't exist, so we'll go ahead and create it. And it's got a PVC associated, and we want it to use the standard RWX to leverage the Filestore CSI here. Okay, so we'll go ahead and run that, and you'll notice that the workload starts getting installed. We'll watch for pod PVC. This usually takes about 3 minutes, I'd say. All right, so what just happened was when we ran the helm command, we made a persistent volume claim, and using the storage class, standard RWX. So what that enabled is it used the provisioner defined inside. Google basically, it told Google to go create a volume, which once it got created, our PVC and PV got bound. Once that was bound, it was able to mount the volume into the container, and now the container is coming up in a running state. Pretty soon you'll see this turn to 1. We'll just wait for it to be ready. Once that's ready, we'll go ahead and log into the K10 dashboard to go through a backup and restore option. Okay, great. So now I'm just going to access Kasten through port forward, and we'll go here, we'll go open a new tab, and we'll say we'll access the dashboard this way. Okay, Kasten, submit. This is our EULA. This is our basic dashboard. It's really got nothing on this cluster, as we know. So what I'll do is I'll go ahead and create a policy to take a backup, right? Snapshot, frequency, we'll change it to daily. In fact, I'll just change it to on demand. I've got no export target defined right now, which we don't care about anyway, because we just want to see it leverage the CSI driver. It's going to go ahead and protect this application MySQL and all resources within it, and we'll go ahead and create a policy. Now we'll go run this once, and it will kick off a backup job in the background. So you'll notice that once we click into the policy, it's protecting all of these items, the workloads, configs, and components, which is basically snapshotting data in the PVC. Just to show you what got deployed, just as a reference, is pod get all PVC. In the namespace, you'll see it's a stateful set with one pod running, a couple of services, and the PVC. It's using the standard RWX storage class. Okay. You'll also see that this namespace MySQL and Kasten IO. So let's come back to make sure the job gets complete. All right. So the backup says it's done successfully. We can click into the job here to get more details, but you will see all of the artifacts that were captured, specifically the volume here with some identifiable information, as well as all these specs that are pertaining to the MySQL Helm chart and application. So we'll go back, all actions completed successfully. So how can we can also do another test to kind of maybe a restore test. So let's just do a restore, assuming there was some failure, and or for testing purposes you want to do a restore. We'll create a new namespace called MySQL restore, and we'll create a duplicate instance. We basically want to bring everything back except for the storage class, because this is a cluster level resource and it already exists. So we'll deselect that we want to bring everything else back. So we will go ahead and click restore. Similar to the backup job, there is a restore action that gets kicked off. So coming back here, we will go ahead and monitor the namespace. So first thing you'll notice, we created a new namespace. K10 does that when you define it in the restore option or restore action right there. And we'll just do pods PVC similar to the other one and just watch for it. It should take just about the same amount of time for everything to come back up in a running state. All right, so similar to the other installation, Kasten really handled all of the heavy lifting for us just by selecting a restore, right? It ensured that we captured the original application in a fully working state. So when you initiated a restore, we created those same resources, handled all of the interaction that's required to ensure that the restored app comes back in a fully working state, as shown here. You can also see that these pods are running on different clusters. If we do the same thing for the restore, they're two different they're running on two different nodes. They're two different set of resources. If you'd like, you can also continue protecting the new workload by going back here. You'll now see 3 applications instead of 2. You can go in here and create a policy to protect this in a separate manner. So thank you for joining me, but this is the end of the session today.